Uh, uh, Hello, good morning, everybody. I do apologize. It just seems that we have had a technical hitch. What I understand, thanks for Tracy to give me a call, is that everybody can hear. So what I will do is that I will start, and then hopefully Marc and Celine then can join us, which I believe they can. And then hopefully everybody will have a great experience. So a very warm welcome to everybody. And thank you for joining myself, Brendan O'Flaherty, Marc and Celine for this morning's webinar. And I'm sure most of you are aware this is, we're in a series of, and I'm sure most of you are aware this is, we're in a series of 6, and this is number 2 of that series. And as I said, the series comprises of 6 webinars in total, giving a unique opportunity to learn, interact, and ask questions from a panel of industry experts. 20, whose funding allows us to create this wonderful webinar series. So a big thank you to them. So now, introducing Marc. Marc, with more than 20 years of experience managing environmental related activities for both the industry, our industry, and the public sector. Marc is now the General Manager of Aria de Brazil, and a member of the board of directors of Aria Technologies. Marc has been involved in structuring major air quality and climate change projects, both on the American continent, but also in Europe. Marc is a member of the Oasis Innovation Hub for Climate Extremes Risk Assessment and Project developing forest fire and resilience tools. And Marc is joined by his colleague, Celine Deandreis, who is a climate scientist, a climatology scientist. So she is a specialist in climate services for water and the energy sector. Her work includes sources of user requests, communication on climate practices, tools, and methods. So whilst we're going through the webinar, please feel free to ask both Celine and Marc questions, and we can answer those at the end of the presentation. So hopefully, Marc and Celine are going to go in.
Oh yes, can you hear me? Is that fine?
Yeah.
Okay, great. Brendan, can you display my presentation, or do you want me to do that? Brendan?
Marc, I think
Oui?
Brendan cannot hear you, so you can share the presentation. It will be better.
Okay, just a second. So here we are. Just a second. So, well, again, thank you, Brendan and Tracy, for organizing this webinar, and also thank you to all the participants for attending this meeting. So, just before starting, Brendan introduced the meeting. So, Brendan introduced Celine as our lead scientist, but this project also involves other colleagues of ours, mainly Gwendoline, Fanny, Pierre, Frédéric, and myself, especially for the business development side of these. Words about Aria before moving on to the presentation. So Aria is an SME specialized in developing solutions for in the atmospheric fields, so mainly air quality, climate change, and applied meteorology. And so, as Brendan mentions, as meteorology. And so, as Brendan mentions, as such, we are part of the H20 project on insurance and health, and we are part of this ecosystem. So if I move on to my presentation, and the one that we prepared with Celine, today we will introduce, in the wake of this H20 project called Risk FP for fire propagation. So this is an innovative weight-based modeling solution for wildfires. So giving you another view of what Risk FP is. So as I mentioned, this is a modeling platform to support managers, investors, and especially the insurance sector in managing the vulnerability of their assets and portfolio. And it's really targeting the fire propagation or fire risk. In that web tool, we have structured mainly 4 modules that we will introduce to you one by one after that. So the first one is the realistic disaster scenario and CO2 release. The second one is risk mapping. The third one is seasonal and climate forecasts for critical days. And the fourth one is wildland-urban interface. So we've been able to test this tool with the Edge 2020, but also with another program that I will mention in the next slide. The Edge 2020, but also with another program that I will mention in the next slide. In different parts of the world, so also different kind of geographies, different type of climate, mainly Brazil, Chile, South Europe, and Australia. So we've been Chile, South Europe, and Australia. So we've been working worldwide, and I think this tool is meant to be worldwide in its application. So the partners, as Brendan mentioned, so basically, we also had a complementary program from France called Booster, which helped us to develop mainly the wild-urban interface module. We reckon that it makes sense to put all those applications under the same umbrella called RISC-FP. But we also thank the support of Booster for that specific development. So the partners, of course, the project is led by PIC, and you have several actors which are very important for that platform. So we are leading the developments and the business development. So basically, with our specialty of modeling and meteorology. We have also Techno Silva, who is a fire propagation specialist and is very active on risk maps and vegetation maps. We have Forestry, which is an insurance specialist, a broker based here in London, and who is very important in connecting us to the, especially to the insurance sector sphere. We have ONFI, which is a small company that was created from the French forest organization, so forest management, and also are responsible for this CO2 module for green gas releases. We have FXTs, which was more on the Booster side, but is very on building vulnerability. We have the University of Aix-Marseille, who develops the modeling module SWIFT for the wild-urban interface, and 2 other partners, which has Valabre. They have a very important knowledge on natural risks, and a competitive cluster called SAFE. So it looks like a bit a Tour de France jersey, but it really shows that we need to integrate several kind of for this work. So it's not just modeling, but it's a whole chain of competence, starting from fuel map to the final results. So a few words about the business model. So basically, this web tool can be used directly by the clients as a subscription, but it can be by the clients as a subscription, but it can be also used for us to make studies. So the client may not need or may not want to have access to the service, and may just need the results. So we can use that same to perform the study and out the results to the client. So that's what I'm always calling one-off consulting. So at the bottom, you have a snapshot of what the main page looks like. During this webinar, we won't be able to showcase directly on the web because of time, but we will produce a few snapshots of the results so that we can illustrate how the results look like, and to give you a better understanding, especially for H 2020. So we had a good case in Australia, mainly three areas, sorry. Two around the Melbourne area in the southeast of Australia, and another one near Sydney, west of Sydney. So that's what is called Zone 1, and Zone 2 and 3 are Wallala and east of Melbourne. So those are the areas that we have chosen with a supporting partner to perform some tests on this for this service. So focused on this Victoria State area, an area of 50 by 50 that you can see here displayed on the map. And maybe I will hand over to Celine to comment about the first module, which is the critical landscape weather patterns, which is a very important and structural item into our proposal. So Celine, could you please maybe introduce those critical landscapes to our audience, please?
Hello everybody. So yes, the critical landscape weather patterns are a concept at the heart of the RISC-FP platform. In fact, it is an empirical fire weather index that identifies severe extreme weather days. Its definition includes fire risk factors related to fuel and weather conditions for a severe extreme bush fire, with associated events are gathered. The second criteria is a criteria of exposure duration in hour that counts the number of hours during which the extreme conditions are reached during a day. So this indicator is derived from hourly or half-hourly record at a representative weather station of the studied zone, and it is used in the RISC-FP platform first to pre-select days the generator will be run. These critical landscape weather patterns are also used to compute risk map of extreme days, and finally they are used as a basis of the forecasting and projection service. Marc, next slide, please. Yeah, so here is an illustration of the critical landscape pattern. So it is for the Wallala zone that Marc introduced. And you can see in the platform here these two plots that provide you information of the number of days that were critical in the past. So here it is for the past period, from 1994 to 2018. And you have for each year the number of year by year. So for example, you can see that the 2009 year was a very critical year with more than 1% of days considered as critical for fire events. And we have also a plot putting the cycle of the critical days month by month. So in Australia, we have October, November, December that are considered as very now, so as I told you, the critical landscape patterns are used to run what we call the realistic disaster scenario generator. So yes, Marc, my next slide, please. The fire events that are available from observed database. Most often, these databases are very poor, mainly in regard to the extreme fire events. So this generator allows the generation of hundreds of realistic scenarios of extreme wildfire, and they can be used to complete the observed ones, and mainly to improve the estimation of the probable maximum loss. First, the selection of days that are considered as extreme in terms of weather and fuel conditions. So this is done thanks to the critical weather landscape patterns. And second, for each extreme days, we can create realistic fire scenarios, running a fire propagation simulation. So in RISC-FP, these simulations are performed with the wildfire analyst forest fire simulator at the partial resolution of about 40 meters. Wildfire analyst software is provided by our partner TechnoSilva, and it's based on the standardized and valid propagation model. This model takes into account detailed information on weather conditions, but also a description of fuel at high resolution and digital elevation model at low to high terrain slopes that are very important in fire propagation. In addition to the realistic disaster scenarios generator, we have developed an additional module in order to provide not only the shape-bound area for each scenarios, but also to compute impact of the simulated scenarios. So by default, the impacts are computed in terms of greenhouse gases emission. So we can provide the fires in terms of CO2, methane, and the other main greenhouse gases. But we can also add other impacts, including financial losses, depending on the data the user can provide. So on the next slide, we have an illustration of a realistic disaster scenario. Marc, I think so. We have first this scenario has been created for specific conditions that the user have to put in the platform. So the first one is the start date. So here we have chosen the 7th February 2009. That is in fact the days of the Black Saturday in Australia. And we have also to provide information on fire start time. So on fire start time, so here we start the simulation at midday. We have to provide information on the spread duration. So here it was a simulation of 6 hours. And finally, we have to provide an ignition point for the fire propagation. Bottom left of the screen, the flame icon that corresponds to the ignition point. So here you can see the result is the shape of the fire simulated by our generator, and you have information on propagation as each of the ISO line corresponds to the burned area after a certain time of propagation. Okay, So we have done some simulation, but I will not give you more details about that. But it was just to be sure that this model work well for the region, for the studied region, so Australia. And what we have seen is that for the two very important fires in the region, the model works very well. It represents wind regime change during the fire. That is a very important parameter for fire propagation. Okay, so now we have the second product that is proposed in the platform is the risk mapping. So this project provides a map giving an overview of the critical areas with regard to the easiness of the fire to spread in the case of ignition. The easiness of the fire to spread in the case of ignition. So this map is based on a risk index that includes 5 classes that takes into account several fire propagation variables such as the flame length and variables such as the flame length, fire line intensity, and rate of spread. And it is computed for each cell grid of the zone, so at the 40-meter resolution. So this map mainly give information on the area in which a fire ignition will be very critical, and it can be used to select appropriate fire ignition point when we want to generate. Now the seasonal and climate forecast module. So in this module we have developed this project allows to predict the potential, provide forecast of the potential exposure to fire risk at both seasonal and long-term horizons. So in fact, we are not providing forecast of fire itself, but of the critical days in terms of weather and fuel conditions. But if we don't have no ignition, we will not have a fire. So this project are computed with 2 European data sets, so the seasonal forecast provided by the Copernicus program and the climate change scenario provided by the international community. So here you can see 2 representation of the seasonal forecast and the long-term projection forecast. You can see we have retrieved the seasonal forecast of the Copernicus program in August, and we have the forecast for the 7 next months from September to next March. And then you can see between the mean normal condition in green and the coming year, the next condition for this year in red. So normally, if the forecasts are good, we should have less critical days in the next for the next season. For the next season. Okay, Marc.
Okay, so excuse me. I will take over to finish. Try to keep the time because we have let's say 4 minutes left to comment a bit about the wild urban interface. Sorry. So this service allows to estimate the damages to vegetation and buildings at the interface between urban areas and vegetation. In that case, is to work at a very high resolution, different from the other services which are slightly coarser kind of resolution. In that case, what we we are really looking at is the impact of the the potential impact fires to a set of houses or to a very limited area, and to understand what could be done to lower the risk possible to simulate cleaning scenarios, for example. So in that case, we use the SWIFT model, which is developed by the University of Marseille, as I mentioned before. So it's a raster-based model, and which really gives a good description and helps do the modeling, not just of the fire propagation, but also the impact that fire can have on the buildings. So all the information related to the materials, to a very fine description of the gardens and all what's in the area is critical for having a good modeling result. So at the bottom, you can see a description on an animation of the fire, going around an area which was cleaned, and this is the photo on the left-hand side, where you see that a 50-meter area was cleaned, and what is the impact through modeling of that measure, the impact through modeling of that measure. And on the right-hand side, you can see a fire that already has happened, and some areas with the houses which were not so much impacted by this fire. So the inputs that we need are basically the maps, building flammability properties, vegetation maps, topography, meteorology, all that has very fine resolution. And also we need to choose the scenario which will be modeled. Of course, the fire propagation simulation, an assessment on the building damages, identification of risk zones. So basically, especially we tested this tool in southern France, and we tested this tool in southern France, and we tried to put into the test this 50-meter legal area around houses. And with that kind of tool, we can assess if, for example, a bigger area should be in order to decrease the risk of fire impact. So I will not go through too many details because we are already done in time, but you can see on the left-hand side in the configuration tools that you can put lots of information about the wind direction, wind speed. You can put lots of information about the wind direction, wind speed, temperature, of course, vegetation, topography. All that is represented on this photo. So I've got a couple of slides after that just to illustrate. So here the little red dots are the security zones around the houses. You can see the different vegetations and the roads are designed on this map. And of course, as for the other one, you need to define what will be the duration of this fire. And you can also configure the building heights and give some finer information about that part of the configuration of the system. So then, of course, going very fast and finalize the presentation, you can see at the top this sort of triangle within and simulated, and coming from different areas, of course. And you can see that the fire gets into the critical zone, and you can then assess the damages of that fire on your assets. I will remain, I think we will have time, but of course, I hand on to you, Brendan, if you want to.
Thank you. Okay. Marc, Celine, thank you so much. What an amazing presentation, and what an insightful one as well. We do have a couple of questions that have come in, from the audience. A couple of questions that have come in, from the audience. So I don't know if Marc, if you wanted to take this, but the question is, do you also estimate the maximum losses?
As Celine mentioned, it really depends on the information we get. So maybe I will ask Celine to answer as well.
Okay.
To complement on that, Celine?
Yes, so in fact it depends on the data that's available from the client. So if we have financial information on the forest or on the building that are in the information on the forest or on the building that are in the area burned, we can calculate from our simulation the maximum loss, because we consider that we will simulate very the most extreme scenario could provide an idea of the probable maximum loss. But it really depends if we have the input data or not. So depending on the client's data, we can calculate.
Okay, wonderful. Thank you. There is one other. Can you configure the system for any place in the world? ? And are there any limitations?
Well, yes, we do need, we can provide the service any place in the world, that's for sure. Depending on the area, the information available may be scarce or not. So the amount of work that needs to be done for the configuration may vary a little bit from one place to another, take Australia, Africa, South America, but for sure that can be applied to any place in the world. And maybe I don't know, Celine, if you want to comment on that, but regarding the maximum areas we can cover for modeling, I don't know if there are limitations in terms of extension of the areas that we can consider.
The limitation, so we have this 50 kilometer by 50 kilometer zone. So if we want to cover a very large area, we have to multiply the number of zones. So it is completely possible, but it needs to configure the tool for a large number of zones. But there is no technical limitation, except that we need to have the input data to do that, also to have the configuration. But
I guess, yeah, sorry. I guess in terms of power, of course, depending on the area you cover, you may run that into one facility or another. It could be a bigger cluster or a smaller computing facility. So that would be the technical choices that the team would done depending on the case. That would be the technical choices that the team would done depending on the case we have.
Okay.
As Celine said, no great technical limitation apart from the different choices that we need to make depending on the case we have.
Okay.
We work on.
Wonderful. Good. Thank you. Simulate 2018 Californian fires. And if so, how accurate were your simulations?
So in that case, the answer is no, because we had to make choices at the beginning of the project on the areas on which we would need to concentrate. So on Australia, so we didn't have the opportunity to simulate any fire in Australia, in California. So yeah, the answer is no.
Okay, all right, thank you. I'm not quite sure if there's any other questions from the audience. So with that thank you. Any other questions from the audience? So with that thank you both very much. It's been really fascinating. And Marc, I know that you've been traveling all this week, eh?
Yes.
Yeah. How's the weather in London?
Oh, very fine.
Okay, compared to where you are.
I didn't use my umbrella that much, so
You still brought one there.
I'm a lucky man.
And Celine, you're in Paris, yeah?
No, I am in Toulouse.
Ah, okay, wonderful, good.
Yeah, but in any case, as we know that the format is has a start and finish, and the period is short. If you have any question or any other doubt, please do come back to us by email or through Brandon and Etienne. We will be very, very happy to answer them.
Absolutely, and I will follow up everybody with the recording and the presentation as well. So everybody will get a follow-up other questions when you do. I suppose just finally is just to remind everybody, as this is a series of 6, and this was 2. The next webinar is next Tuesday, and that is on the 22nd, and that's at 10 a.m. British Summer Time and 11 a.m. Central European Time. And the topic on Tuesdays for smallholders through understanding yield losses caused by climate change. So the webinar will explore the use of technology in understanding those yield losses caused by climate change. And our panel, so we're very, very lucky to have such amazing experts in the field. So amazing experts in the field. So our panel on Tuesday is Dr. Christophe Gournat, who's an agricultural economist, and his colleague Felicitas Roeg, who is a research analysis, and they're both from Potsdam Institute for Climate Impact Research. So we're very much looking forward to that. So with that too, and again, I'll also, and finally, before I end, I'd like to thank, of course, Oasis Hub and all my hardworking colleagues there. But no doubt we will follow up with further information around Oasis and about what we're doing and all the great tools that we have and all the new tools that we have, and how we can share our tools that we have and all the new tools that we have, and how we can share our data with you guys as well, and how you can support the community and further webinars like this as well. So fantastic. So Celine, Marc, thank you.
Thank you. Have a good day.